All right, guys, this is the last 5 or 6 slides about uh, the rest of the chapter for chapter 2. Hopefully you're able to understand this. If you have any questions, let me know and I'll try to answer them to the best I can. So Lewis acids and Lewis bases make up the majority of the reactions in organic chemistry. We talked about Lewis acids, we talked about Lewis bases. Two other terms that we frequently use in organic chemistry as opposed to Lewis acid and Lewis base are electrophiles and nucleophiles. Right? Every chemical reaction in organic chemistry has to do with electron-rich species reacting with electron-poor species so that the overall chemistry can make it have lower energy, because like we said, that's the goal. Right? So a Lewis acid is also referred to as an electrophile. If you remember, our Lewis acids have a positive charge, usually, sometimes, not necessarily all the time, right? So they want to be neutral, so they're going to be attracted to electrons, right, or electron-rich species. That's why they're called electrophiles, right? Electro for electrons, philes for loving. So they love electrons. That means the other thing that's going to react them, the Lewis base, that's going to be called a nucleophile, which is going to be attracted to the nucleus, which is the protons that are in there. Right? So electrophiles react with nucleophiles. It's the same thing that we've done when we classified something as a Lewis acid or a Lewis base. Right? We just got to figure out which one is going to be which one. Right? So in the example we had before, right, which is on here, BF3 is the electrophile and water is the nucleophile because of the positive and negative charges. So one of the most challenging parts of organic chemistry is figuring out what reacts with what and how they come together, identifying the electrophile and identifying the nucleophile. So for this particular example, we don't remove the electron pair from the Lewis base. It is physically reacting with it, forming either some sort of new bond. Sometimes we do that, sometimes we don't. So this is a very specific example of Lewis acid-base reactions that form one new covalent bond. It's hard to see what's the electrophile, what's the nucleophile when you first get started out, but for the most part, you can kind of figure it out by looking at the thing that has the most electrons. That's going to be the nucleophile. The thing that's electron deficient is going to be the electrophile, and then those things react. So if we take a peek at this Lewis base, this bromide nucleophile, is going to attack the Lewis acid, which is this carbocation, to form this brand new bond right here. Right? That is lower in energy, so that reaction is going to occur every single time. On the bottom example here, right, we see that these lone pairs, one of those three, it doesn't matter which one, is going to attack this electron deficient aluminum, right, to form this new bond. And this is a Zwitterion, right, this negative and positive charge here, right, but same thing, much more stable than if it were apart. Other types of Lewis acid base reactions, one is broken and another is formed, and this is the more common type of organic chemistry reaction, mainly because it deals with carbon, and carbon is only allowed to have 4 bonds, and if you have more than 4 bonds, then that breaks the octet rule for carbon. So when you're drawing them, always keep in the following steps. Always identify the acid and base first. That's the hardest part because you have to be able to recognize those. So sometimes you use the appendix in the back of the book. Other times you'll just get used to it and you'll know kind of what's going on. All right. Next, you draw the curved arrow from the base to the acid, right? Nucleophile to electrophile every single time, and that's super hard to do because it just kind of feels like when you first start out, you just kind of feel like you're drawing arrows everywhere. But the arrow always starts from the electron pair, which is either a lone pair or a double bond, and it always goes to the electron deficient atom, which is the Lewis acid. Then you're going to count electron pairs and break the bond when you have to keep the correct number of valence electrons. Remember, for carbon, it always needs to be 8, right? No exceptions, right? When you're doing reactions. Now you can make some sort of carbocation that only has 6, but you know that that's going to be pretty unstable. Right, so here's an example of a Lewis acid Lewis base reaction that involves a pi bond, right? So most of them you'll have carbocations or you'll have lone pairs, that type of thing. You're going to not always have that. So this is a reaction we'll learn about a little bit later on in more detail in a later chapter. But this is a nucleophile and an electrophile reacting with each other, right? The pi bond is electron rich, so it's a nucleophile. The Lewis acid, that HCl, is electron deficient, right? So it is going to want to react with something that has a bunch of electrons in it. The tough part is knowing where the arrows come and go. So when you look at this, you're going to know the arrow always starts at the electron rich one, right? So that's right here, right? That's your electron rich. And the way that you can recognize an alkene as being electron rich is, if you think about it, it has 4 electrons in between those 2 carbon atoms. So that's going to be electron rich. So that's going to attack the electron deficient atom, that hydrogen, right? But then if you think about it, hydrogen's only allowed to have 1 bond. So then this electron has to push off and form the chloride ion. And that's exactly what happens in this situation. Right? So the Lewis base, which is the nucleophile, attacks the electrophile, which is the hydrogen. The electrons are pushed because hydrogen is only allowed a duet, and you form a new bond. Right? Now, when you look at the products of this, you'll notice that you're forming this carbocation and you're forming the chloride. The charge is the same on both of them, which is very important that you always make sure that the charge is the same. This is the first step of a multi-step reaction. So hopefully you'd say, well, Brandon, you said that everything wants to be more stable. Well, why would this even react when you're forming something that's a carbocation, and we know that carbocations are not stable? And the reason is it's going to react with the chloride in a subsequent step to form different types of products. So you'll get a lot of experience and work doing this in the Connect homework. So hopefully you will, if you have questions on that, you'll let me know over the next couple of days. Okay. So the lots of stuff with this chapter. Everything is acid-base chemistry. You just have to pick out the acid. You have to pick out the base. You have to pick out the nucleophile. You have to pick out the electrophile. Get those figured out, and hopefully these activities will be a lot easier moving on into the future. So if you have any questions, please send me a message on the Remind app or send me an email. Otherwise, good luck studying. I'll answer a few questions at the beginning of class on Wednesday, and then we'll take the test. All right? Have a good weekend. Bye-bye.